Hey everybody, in this video we're going to talk about graphing the inverse of a function given its graph. But before we do that, let's talk a little bit about what a function and its inverse will look like. So when we're talking about graphs of inverses of functions, the notation for inverse of functions is f to the negative 1 of x or f to the negative 1, and we say f inverse of x or f inverse. This f inverse is kind of a nickname, okay? But it's still a function of x. The graphs of the function of x and its inverse are symmetric with respect to the line y equals x. So what does that look like? Let's see some examples here. We can see this blue line. If I were to reflect it across the line y equals x, it would land on top of the red line, right? Now, let's take some points from this blue line. This point right here is 10, 0. And this point right here, the y-intercept, is 0, negative 5. Now look on the red line at what the x-intercept is. The x-intercept is negative 5, 0, and the y-intercept is 0, 10. When we reflect our line or our function across the line y equals x, we're basically swapping our x and our y values. That's what an inverse function is. Okay, let's look at another example. Here, let's let the blue function be f. Let's go ahead and take this point right here. It's about at 5, 2. Let's look at the red function, which we'll call f inverse, because it is a reflection across this line y equals x. If we were to swap the x and y points, or the x and y values of this points, we would get the point 2, 5, and we would expect that point to be on our inverse. 2, 5 is right here, which is on our inverse function. Okay, so now let's talk about when we are given a graph, how to graph an inverse function. So we're given the entire graph of the function f, and we're told to graph the inverse. Okay, so we know with functions and their inverses that they're going to reflect across the line y equals x. So here's my line, y equals x. Now on my function f, I'm going to write out some points here. And I'm going to check like important points at the end or at where the graph changes. And this would be point 6, 7. And this is point 4, negative 4. And my next one is at negative 2, negative 5. Okay. Now, when I go to draw f inverse, it's gonna, all these points are gonna be reflected over the line y equals x. So I swap my x's and my y's. So I should have a point at 7, 6. 7, 6 is here. Can you see how this point 6, 7 is reflected across that line y equals x and becomes 7, 6? The next point is going to be negative 4, 4. So I just swap my x and y. So it's there. And that is this 4, negative 4 point flopped over. And then I'm going to have my point negative 5, negative 2. And then I can connect them like this, and I've graphed the inverse function of the original graph that I was given.